Hello and welcome back. This is Mr. Wyrick, and I'm here today to talk to you a lesson about lesson 6.4, the fourth lesson from chapter 6. We're starting back up after the break. If you're in my class, if you're in another class watching this, it's also probably after the break, so welcome back. Today we're going to be talking about rectangles. Rectangles are a specific kind of parallelogram. They have four right angles. So they have all the same properties that parallelograms have, with the opposite sides being congruent and parallel still. The diagonals will bisect each other still, just like in a parallelogram. But the additional quality of rectangles is, of course, the four right angles. That's the identifying feature. Now, if you look in your book on page 424, 425, it should have this information that you need to make sure you add to your notes. These are the theorems that you'll be dealing with when it comes to rectangles, and that's if it is a rectangle, then the diagonals are congruent, and then the converse of that is true as well. If the diagonals are congruent, it is a rectangle. The only way those diagonals are going to be congruent in a parallelogram is if those angles are shifted up to 90 degrees and all four of them are 90 degrees. When we get into squares and the properties of squares, it's going to be, it'll have all these same properties as well, because a square is a rectangle and a rectangle is a parallelogram. So all these same qualities are building on one another, so you have to make sure that you identify the shapes properly and make sure you know which one it is that you're talking about. It'll probably be to your benefit, since we've had quite a break in my class, to go back and take a look at some of the properties in parallelograms. Go back and take a look at those first few lessons from chapter 6, number 1, 2, and 3, or refresh yourself with the videos and remember those properties of parallelograms as we move forward. If there are any other questions, make sure you ask them in class.